Hey guys, Mr. McKinney here, just going through U substitution. This time we'll be talking about how to do definite integrals using U substitution. Definite integrals, again, refers to the area underneath the curve. You can use the same process to calculate the antiderivative, but then you have to remember to do something with the limits. And the fundamental theorem of calculus basically just says that you can do capital F of B minus capital F of A to calculate the area if we're taking the integral of f of x, little f of x dx, going from A to B. Okay, so that should have been covered in the 7.1 video series, and now we're going to see how to do all that with uSub. So let's look at this problem. I'm going to go through this two different ways. So this is what I consider to be the easier way to do this type of problem. Basically, you go to U, you convert your limits into U limits, and then you never go back to X because we're just trying to figure out what the area underneath a curve is. So if I graphed this function, what would the area underneath it between 0 and 1 be? That's what this question is asking us to figure out. So I would start by finding my U function. If there's a root, it's usually what's underneath the root because otherwise things get really ugly. So my U function would be x to the fourth plus 9. My du would be 4x cubed dx. Now at this point, you can either multiply by 4 on the inside and 1/4 on the outside, or you can solve this for dx and then cancel out your x cubed and you'll end up with a 1/4 that you would then move outside later. It doesn't matter. I like this way, so I'm going to show it this way. Now, since it's definite, we also, in addition to converting the functions into u, we also need to convert the limits into u. So we would say that u of 0, and then I'm just going to plug in 0 into this equation. So 0 to the fourth plus 9, 0 plus 9 is 9. And then u of 1, plug in 1 into this equation. So 1 to the fourth plus 9 is 10. So I can convert this entire expression into u and then just work it out and never go back to x's. And I'll show you what I mean. So instead of this original problem, we're going to rewrite it as 1/4 times the integral. We're not going from 0 to 1 anymore because that was when we were dealing with x's. X was going from 0 to 1. But now we're talking about u. And u is going from 9 to 10. Because when I plugged in x as 0, I got that u was equal to 9. When I plugged in x as 1, I got that u was equal to 10. Now my 4x cubed dx is what we said du was going to be. So I have du divided by, and then instead of the square root of x to the fourth plus 9, we're going to say it's the square root of u. Now let's rewrite it so that it matches one of the formulas that we can use. So we're going to say that this is u to the negative 1/2 du. So then I've got the 1/4 out front times, when I take the integral here, I'm going to go u to the positive 1/2 divide by 1/2. I don't need a plus c because it's definite, but now I need to evaluate it going from 9 to 10. So I need to plug in 10 and I need to plug in 9. Now I can either simplify all of this and then plug in 10 and plug in 9, or I can plug in 10 and 9 and then simplify it. If I plug in 10 and 9 and then simplify it, I'm going to have to simplify it twice. So I'm going to go ahead and simplify it first. So instead of dividing by a 1/2, that's the same as multiplying by 2. So 1/4 times 2 is 1/2. And then all we have to do is plug in 10 and plug in 9. So we'd have 1/2 times 10 to the 1/2 minus 1/2 times 9 to the 1/2. Now you could stop here or you can keep simplifying, so I'll simplify a little bit more. You could write it as 1/2 times the square root of 10 minus 1/2 times the square root of 9. We know the square root of 9, so you could do 1/2 root 10 minus 1/2 times 3, which is just 3/2. This is likely the answer you'd see, or maybe 1/2 times root 10 minus 3. But any of these is fine. Any of these ones that are kind of boxed in the squiggly. So you don't ever have to go back to x. If it's an indefinite, you have to go back to x because your answer needs to be in the same variable that you started with. But the area underneath this curve from 0 to 1 and the area underneath this curve from 9 to 10 are the same thing. So I don't have to go back. I can just leave it like this. All right, now, like I said, this is what I consider to be the easier way to do this problem. When I was in high school, I wasn't taught that way. I was taught to go to u and then go back to x at the end. So I'll show you what that would look like. You'd start out the same way. You'd say, okay, u is x to the 4th plus 9. So du is 4x cubed dx. So again, you need your 4 and you need your 1/4. And then you can say, okay, this is 1/4 times the integral of du over the square root of u. And then you don't worry about changing your limits. Now, I wouldn't want to just say 0 to 1 because that wouldn't be true. It's now from like x equals 0 to x equals 1. If I didn't put x equals, if I just said 0 to 1, like this statement would not be true. So it's the integral of u, but x goes from 0 to 1. So the notation gets really confusing. But then you would say, okay, 1/4 the integral from x being 0 to x being 1 of u to the negative 1/2 du. So then 1/4 integral from x equals 0 to x equals 1. Sorry, it's not the integral anymore because now we can actually take the integral. So the integral of u to the negative 1/2 would become u to the positive 1/2 over 1/2, not plus c, but now I'm going to plug in x is 0 and x is 1. This is going to simplify the same way as before. It's going to be 1/2 times the square root of u when x is 0 and x is 1. But I can't plug 1 in for u because that's not what u was. So then I can plug my x function back in. So 1/2 times x to the 4th plus 9 underneath the square root, going from x equals 0 to x equals 1. Now I don't really need the x equals anymore because the variable matches. And now I plug in 1 and I get 1/2 times the square root of 10 minus 1/2 times the square root of 9, which is the same thing I got before. But you don't ever have to go back to x's. And if you do, like if you do it this way, it gets really obnoxious because you have to like write x equals the whole way to show that the limits are a different variable than the integrand or inside the integral. So I don't recommend doing it this way, but other people might help you out and might do it this way. So this is what they would be doing. So you can go back to x's at the end if you don't ever convert your limits, but I don't recommend that way. What I recommend you do is change your limits from x equals to u equals, and then just stay in u the rest of the time, and then you never have to go back to x. All right, so here's a couple of whiteboard problems. So use u substitution with definite integrals to work both these out. Hit pause, see how you do, and then we'll talk through them in a second. All right, let's see how you guys did. On the first one, you should have gotten 1/3. On the second one, you should have gotten -2. And on any definite integral problem, you can always check your answer by hitting Math 9 on your calculator. And you can check to see if you got it right. So on the first one, the u function would be 1 minus r squared. Du would be -2r dr. So we need a -2 on the inside and -1/2 on the outside. Convert your limits. Now when you plug in 1, you get 0. And when you plug in 0, you get 1. So the limits essentially get flipped, but that was just a coincidence. It's not like you flip the limits. It's not a rule. It just happened to get flipped on this one. So then we had a -1/2 out front. Rewrite it as the square root of u du. So u to the 1/2. So u to the 3/2 over 3/2. That -1/2's just been hanging out front. I'm going to flip this and multiply it so the 2's cancel out. So -1/3. And then I need to plug in 0, minus, and plug in 1. 0 to the anything is 0. 1 to the anything is 1. So this whole part is -1. -1/3 times -1 is +1/3. Second one, similar idea. U is x squared plus 9. Du would be 2x dx. So I need a 2 here and a 1/2 out front. When I plug in -4 and 0 into my u function, I get 25 and 9. 25 goes on the bottom, 9 goes on the top. This would become du over root u, so that's u to the -1/2. So when I take the integral, it becomes u to the +1/2 divided by half. This half and this half end up canceling out. So you basically just have the square root of u evaluated from 9 to 25. So square root of 9 minus square root of 25. 3 minus 5 is -2. All right. And again, hit Math 9 if you're on the AP exam to check and see if you did it right. Okay. These last couple of problems, this one's not really uSub, but we usually teach it on this day, so we're going to throw it into these videos. So we want to find g of x in terms of x. I'm going to show it two different ways. So first, let's just use the fundamental theorem of calculus. T dt matches one of the formulas that we know. So the integral of t would be t squared over 2. I don't need plus c because it's definite. So it's t squared over 2 going from 3 to x. So then I'm going to plug in my x squared over 2, minus plug in my 3 squared over 2. So my answer would be 1/2 x squared minus 9/2. I don't know why that just happened. So g of x equals 1/2 x squared minus 9/2. So we're just using the fundamental theorem of calculus, the f of b minus f of a. There's another way to think about this, so I'm going to go through that as well. Another way to think about this is to say, okay, well, I know that derivatives and integrals undo each other. So I can get g prime of x. So I can take the derivative with respect to x going from 3 to x of t dt. And the other part of the fundamental theorem of calculus says if this variable matches this variable, and if this variable matches this variable, basically you can just plug it in. And so g prime of x would just plug in x, and I would just get x. So g prime of x would be x. And then I want to know what g of x is, so I need to take the integral here. So I'd say, okay, well, g of x is going to be the integral of x dx plus c. And so when I take the integral of x, the integral of x dx, and since it's an indefinite integral, it'll have a plus c. So moving up here, the integral of x would become x squared over 2 plus c. Now to figure out what the c value is, I need a point on the initial problem. Now what I can do is I can say, okay, well when x is 3, the area underneath here is 0. So g of 3 would be 0, because if I plugged in 0 on the top here, if I plugged in 3 on the top here, I'd have the same limit on the top and the bottom, so the area would be 0. Okay, so then I know that g of x is equal to x squared over 2 plus c. And when x is 3, g of x is 0. So then I can solve for c and get that c is -9/2, and then plug it back in and get g of x is equal to 1/2 x squared minus 9/2. So this is just another way to get the same answer we got here. Hopefully that helped connect the dots for a few of you guys. All right, here are a couple of whiteboard problems. So go ahead and try to work these out. This one's like the one I just did. This is going to be a uSub problem. So work both these out, hit pause, and then hit pause again or play when you're ready to go over them. All right, let's see how you guys did. On the first one, we're just doing the integral and then using the fundamental theorem of calculus. T to the third turns into t to the fourth divided by 4, evaluated from 2 to x. So plug in x, subtract, plug in 2. X to the fourth over 4 could be rewritten as 1/4 x to the fourth. 2 to the fourth is 16 divided by 4 is 4. So g of x would be 1/4 x to the fourth minus 4. Down here, we'd say that u is equal to sine of x. Du would be cosine of x dx. Now, some of you guys are going to want to rewrite this as sine of x to the 11th power. It'll make more sense when you see it this way. So then it's really just u to the 11th power du. So it's u to the 12th over 12 plus c. And then you can rewrite that as 1/12. And instead of u to the 12th, u was sine of x. So it's sine of x to the 12th plus c.